Okay, we are going to embark on a classic chemistry exploration, uh, the candle experiment or the candle lab. We're going to burn a candle and we're going to watch it. And it doesn't sound terribly exciting, but we're going to do some other fun things with it. And this is a classic experiment that was started way back in 1825 by a scientist, famous scientist known as Michael Faraday. Faraday doesn't get a lot of recognition in classic chemistry classes, although he should. He gets more recognized in physics classes. But regardless, a big powerhouse, pun intended, back in the day regarding science. You should be familiar with his name. And let's see what he did and what conclusions he came up with, and you are going to come up with regarding the simple task of burning a candle. All right, let's get started.
So here we see a candle just burning. Note the flame, note the candle, note the wick, note the wax, all the pieces. You're going to take up to 8 observations. Actually, no, you're going to take 8 or more observations regarding this happening. Here are some stills of the candle and the candle flame. You can clearly note the different parts of the flame. You will also want to note again the wax and what's going on with that during the burning of a candle. So check it out. And here we show me tilting the candle. In this exercise, we're going to take our lit candle. We're going to light a secondary candle. And then we are going to blow out the main candle and bring this lit candle near the main candle while the smoke from the main candle is traveling away from the candle. And let's see what happens. Let's try that again. For this exercise, we are going to have the candle and the flame of the candle interact with a wire screen. We're going to call it a wire gauze. I'm going to take the wire gauze, I'm going to go over to the top of the flame. Let's get some better angles of that. This one is tough to see, but let's see how the flame interacts with the outside of a beaker filled with cold water. You might notice a little fog building up there. Okay, we're going to do these last two tests together because they happen pretty quickly and consecutively. We're going to take our candle, it's in the dish. It's the candle secured at the bottom of the dish because I melted a little wax and melted it so that the candle and the dish are together. So when I pour in some water into the bottom of this little dish, the candle doesn't try to float away. So I add some water there. And I'm going to take the Erlenmeyer flask. I'm going to put it over the candle. Like such. I'm going to put the mouth of it just over it, just like, kind of like that in a moment. And then after it's done, I'm going to pull the Erlenmeyer flask off and I'm going to test the gases that are inside the Erlenmeyer flask with this liquid. It looks like water, but it's not. In here is lime water. And if something happens, it shows the presence of a chemical. We'll talk about that in a minute. So let's begin by taking the Erlenmeyer flask and putting it over the candle. Now you have to watch this, and things happen kind of quickly, and the succession of events, the order in which the events occur, is important. So make sure you're watching carefully, or make sure you go and rewind in a little bit. All right, so here we go. Put this over. Okay, pretty neat. Now what I'm going to do is I'm going to turn this over. I'm going to let the water out. I'm going to turn it over and off to the side here. I'm going to pour in the liquid, lime water. I'm going to cap it to trap those gases. I'm going to give it a shake. Make sure I get that liquid and the gases mixed. And you'll know that the liquid, I'll pull this to the side here, got pretty cloudy. And that means that if lime water reacts with carbon dioxide, the lime water gets cloudy. Now we'll talk about why this is later in the year, but that's a test. It's a positive test for a lot of carbon dioxide, which obviously wasn't in the lime water before, because the lime water was in the graduated cylinder and it was clear earlier. Okay? All right, check that out. So now we're done with all the observations. I hope you have filled in those observations in the observation form. Now you have to go and tackle the analysis questions. Please have them done and turned in by the due date. For now, good night.